Alright everybody, today we're going to be talking about the circular queue. Before we get started, I would suggest that you increase the speed playback of this video so that you can learn it a lot faster. Specifically, we're going to be talking about the theory behind the implementation of the circular queue. There are many types of queues. There's a simple queue, queue with linked list, circular queue, array queue. But today we're going to be talking about the circular queue, which is like the main dynamic queue. So we just dropped one function which is full because it's dynamic. It's never going to be full. Still follows the first in first out method. So let's go ahead and have a look at the theory. Alright, so here we are in memory. The first thing we have to do is check if empty. So our check if empty is going to simply check if front and rear are null. And obviously, since we have no nodes in the data structure, they're going to be set to null, so it'll return true. Let's go ahead and work on the enqueue. So for the enqueue, we have to create a new node. Alright, so here's our new node. It has a pointer for the next node, and then it'll have data. So we'll go ahead and fill in the data from the user, and then what we have to do is set the front pointer to it, and then we have to set the rear pointer to it as well, since it's the only one in the data structure. If we enqueue another one, we have to create a new node. Alright, here's our new node. Then we have to get user data, so 2. And then what we have to do is set the pointer of the last created node to this new node, like that. And then we have to change rear to this new node that we just created, like that. And then this would be the same process for any other nodes that you create. Let's go ahead and figure out the dequeue function. So for the dequeue function, we have to have a temporary pointer. So we'll call this temp, and it's a pointer, and we point it to the first node in the data structure, because remember, this data structure follows a first in first out. So the first one that we put in was 1. And so that has to be the first one out. So we point the temporary pointer to that first one. And then what we can do is change front equal to whatever this node points to, which is this. So we point there. And then we can delete temp because this is no longer in the data structure. So we just delete this. Alright, so let's dequeue this one as well. We have to have our temporary pointer, and then we point that to this. Now this is kind of special because it's the only one in the data structure. We have to know what we're setting front and rear equal to, so we'd have a condition if the one that we're deleting has a next node of null, which this is pointing to nothing right now, so it's null. Then we would set front and rear equal to null, so these would just become null pointers. And then we could delete this data point because it's not in the data structure anymore. Alright, so the peek and traverse are going to be the pretty much same implementation as the array. Those are pretty self-explanatory, and we'll work on those when we're actually coding. I want to discuss the difference between a simple queue and a circular queue. So let's say we have a bunch of nodes here. Alright, so this is what a simple queue would be. We have a chunk of memory with all our nodes in it, and they're each pointing to each other. And the problem with the simple queue is that when we dequeue one from the front, we aren't going to be reusing it. So what happens is, as we add data, it's just going to be adding on and on to the end of the memory. But with the circular queue, we have these nodes again. That's pointing there, and then instead of this pointing to null, we have the last node pointing back to the first node. So that's why it's called the circular queue. Now we'll be reusing memory that we deallocate. So when we push a new node, we have that like that. All we would do is create a new node like that, and then we would link the last created node to this node, and then we set the last node to the front node, just like that. So that's why it's called a circular queue. We're basically, the advantage of this is that we're reusing nodes that we've deleted. Alright, so that was the theory behind the circular queue and the simple queue. So let's go ahead and implement the circular queue with code.